Hi everyone, welcome back to Life Technologies YouTube channel, and thank you so much for watching and supporting our content. So this is another episode of our Huawei Lab simulation series, and in this episode we will be demonstrating to you how to configure static network address translation on Huawei devices. So we know that network address translation is a very common application on networks, and it's used for translating private IP addresses to public IP addresses. So we know that many times on our local area network, we are always configuring private IP addresses because we don't have enough public IP addresses. So we configure private IP addresses, and we know that private IP addresses cannot access the internet, or they cannot be routed over the internet. So we need to have a way in which we can achieve the communication by ensuring that devices on a local area network can be assigned public IP addresses which will be used to access the internet. So this is the primary goal of network address translation. We are mapping private IP addresses to public IP addresses to allow devices that have private IP addresses to access the internet or to be routed over the internet. So we know that we have different types of NAT. We have static NAT, we have dynamic NAT, we have network address port translation also, which is NAPT. But in this episode, we are just focusing on static NAT. So with static NAT, the administrator manually configures a mapping between private IP addresses and a public IP address. So this is one-to-one mapping. You have one private IP, you need to assign it a public IP. So this one still doesn't help us because we still need, if you have 100 devices, you still need to have 100 public IP addresses. But in a small network where maybe you have only 2 devices or 3 devices, you can still go ahead and use static NAT, provided that you have enough public IPs that have been assigned to you and you can do the one-to-one mapping. So in this episode, we are just demonstrating to you how to configure static NAT on Huawei devices. So you can see that from the topology, we have 3 PCs. So we have PC1, we have PC2, and we have PC3. They have been assigned private IP addresses 192.168.10.0/24. And we have a switch, so the switch is connecting the 3 PCs, and then we have the gateway router. So the gateway router is the one that will be performing network address translation to allow these PCs to access the server that is on the internet. So we have public IPs configured between the AR1 and R1. This is 200.200.200.4.0/24, and then we have the server also has a public IP configured. So we need to do the configuration, NAT configurations on AR1 so that we can do a mapping from private IPs to public IP. So all the 3 PCs will be given a public IP, and then we should be able to demonstrate that they are able to access the internet using the public IP that have been assigned. So to start with, this is the topology on ENSP. So I've configured the PC IPs. If we check the basic config, you can see that we have IP 192.168.10.1 assigned. We have also configured the gateway to the IP that is configured on the router. So this is 192.168.10.254. Same thing has been done on PC2, it's .2, and then same has been done on PC3. This is 192.168.10.3. So the gateway will be 192.168.10.254. So let's start by configuring AR1. So on AR1, first thing, we need to configure the sysname. So I will go into the configuration mode and I need to specify the sysname as AR1. Once I've configured the sysname, I just need to go ahead and configure the interface IPs. Gig 0/0/1, we will give it an IP address of 192.168.10.254. mask is 24. We need to make it 24, not 25. So we've configured the gateway. We can try to ping the gateway from the PCs. So from here, if I try to ping 192.168.10.254, you can see that we are able to ping the gateway. So it should be the same for PC1, PC2, and PC3. So we also need to configure the point-to-point IP address between R1 and R1. So I'll go ahead and do the configurations on this interface connecting to R1. So this is interface gig 0/0/0. I'll give it an IP address of 200.200.200.1. Mask will be 24. And then I will do the configurations on R1. So R1 we need to do the same. So on R1 we have the sysname set to R1, and then I need to configure the interface IP addresses. So this is gig 0/0/0. I'll give it an IP address of 200.200.200.2. Mask is 24. Then we need to configure the other interface connecting to the public server. So this is interface gig, no, this is Ethernet. So this is Ethernet 0/0/0. I'll give it an IP address of 192.198.200.200.1. Mask is 24. So this is also a public IP. Then can check the IP configured. This is 198.200.200.100. The gateway is configured as 198.200.200.1, which is the IP configured on R1. So once we've done these configurations, remember, for us to be able to reach the server via R1, we need to have some dynamic routing protocol. So we will just do some OSPF configurations between R1 and R1 so that we are able to have dynamic routing between the two routers. So on AR1, I'll configure OSPF 10 and then area 0, and I will advertise everything. Network 0.0.0.0 can give the wildcard mask. So I will do 0.0 just to no, this one will cause problems because we'll advertise also then IP of connecting the PC, the gateway PC. So I will undo this command, undo network. This is, let me just delete undo OSPF 10. Yes. So I'll configure again OSPF 10, area 0, and then I'll do network. This is 200.200.200.0. Mask is 0.0. Remember, it's the wildcard mask, the reverse. So this is it. Then on R1, we need to do some configuration of OSPF. So OSPF 10, I'll do area 0. And then now here I can use the network 0.0.0 and the mask so that we are activating OSPF on all the interfaces. So we expect the OSPF to come up. You can see that the adjacent is coming up. We give it some time. Display OSPF neighbor. It's still in two-way. Let's give it some time. Display OSPF. So now it's full. If I display OSPF peer brief, you can see that we have an adjacency between R1 and AR1. So from AR1, we should be able to ping the server. Remember the IP was, so if I ping 198.200.200.100, we should be able to ping the server. So that is it for the basic configuration. Now we need to go ahead and do NAT configurations on AR1. Remember, we are doing static NATing, so we need to map the IP addresses of PC1, PC2, and PC3 to some public IP addresses so that they are able to access the server. From here, if we try to ping the server, so if I try to ping 198.200.200.100, you can see that we are not able to ping the server. because we cannot use the private IP to access a public IP. So we need to do some configurations on AR1 so that we are able to do the NATing. So these are interface configuration. With static NATing, we'll be configuring the mapping on the interface. So I'll do interface gig 0/0/0, and then you need to use the command NAT static. You can use a question mark. We start with the global IP. So with the global IP, we assign a public IP that will be used for this host. So we start with 200.200.200. We've configured .1.2 between IR1 and R1. So I can configure maybe, let me say .10. And then you can always use a question mark. You need to specify the inside IP. So the inside IP will be 192.168.10.1 for PC1. We need to do the same for PC2. So for PC2, we can give it .11, and then we need to .2, and then .3, we will give it .12. So .12, and then if I display this, you can see the configuration. So these are the 3 lines that we need to do or to configure to ensure that we have static NAT enabled on these devices. So remember, it's static NATing. We are mapping a public IP to a private IP, or a private IP to a public IP, depending on the direction of the flow of the traffic. So now we have NAT configurations in place. We can now go ahead on PC2 and try to ping the IP of the server. So when you try to ping, you can see that now we have communication, and the communication is happening using the public IP. So whenever I do a packet capture on this interface, I expect to see a communication between PC2 and the server using the public IP and not the private IP. So I'll do ICMP, and then I will initiate a ping again. So on PC2, if I ping, you can see that we have, you see the source is 200.200.200.11, the IP that we've configured. The destination is 198.200.200.100, and the reply is the same. It's 200.200, the server IP, and the destination is, the source for the reverse or the return traffic is 198.200. The destination will now be the public IP that has been assigned on the public IP that has been assigned on the PC when we did network address translations. So we can also do for PC3, if I were to try and ping .100, you can see the packets. So we have ICMP packet coming in, and you see the IP. The IP of this PC, it's now 200.200.200.12, and the destination is still the public IP of the server. So you can easily have communication through AR1, which is doing network address translations. So on this PC, if I display NAT session all, let's see, display NAT session all, we expect to get some information. Let's give it some time, and this command, it takes time to run. We expect to find some mapping that we've configured on this router. So the big challenge with static NATing is that you need to do manual mapping between the different the public IPs and the private IPs, which is a lot of configuration that you will make if you have so many hosts on your network, and many times we also don't have those many public IP addresses. So this is rarely used on production network, but you need to know how static NATing is implemented. So I've done another ping. Let's see whether we are able to get the NAT session table information. So this router R1 will have a NAT mapping table. that will be having a mapping between the private IP address and the public IP address. So whenever there is traffic coming in either direction, there is a mapping that is happening on AR1 to direct this traffic towards the correct destination. Let's see whether we have the mapping. Yes, you can see that now we have our NAT session table. You have 192.168.10.2. It's mapped to 200.100. It's mapped to 200.11. So this is the public IP, this is the private IP. 192.168.10.2 is mapped to this public IP. And this is the NAT info. So it's very easy to implement static NAT. Just to show you the configurations again, under that interface, it was interface gig 0/0/0. Then if I display this, you see the command that we've used to implement static NATing on Huawei routing devices. So thank you so much for watching this session. If you've enjoyed this session, kindly remember to subscribe to our channel and also to share with your connections. So see you again in our next episode. Bye.